All right. Okay, so we are going to talk about the unit circle. Either of you heard of the unit circle before?
I have some parts of it, but not really.
It's kind of there, maybe a little bit. You would have seen it at the very end of geometry. If you did like honors geometry, there's a possibility you would have seen it then. But it really just depends, because if you did honors geometry last year or something with NTI, then you might not have seen it. If you did see it, it might have been 2 years ago. Like, just, yeah. So, what the unit circle is it's a circle, literally circle. And we call it the unit circle because we're going to say that the radius of this circle is equal to 1 unit. All right? Radius of the circle.
Okay, we have to do radians.
What was that?
We have to do radians.
We're going to do radians, yes. But we're going to wait and do those on Friday. So today we're only talking degrees, okay? All right, if you flip the page, we're going to go back and forth a lot between these two pages. This is kind of the shell of a unit circle, all right? And so what we're going to do is we're going to slowly start filling in all of these values. Our goal is to tell the XY coordinate points at each of these locations around the unit circle. You see all the little points? Now, each of these locations represents an angle measure, okay? And the coordinate points represent sines and cosines of those angle measures. So instead of me saying find the sine of 45 degrees and you having to use trig in the calculator every single time, we are going to be able to have values that these directly correlate to, okay? In order to figure out all of those coordinate points, we're going to use the 45, 45, 90 triangle and the 30, 60, 90 triangle, all right? Before we get into the triangles, though, we're going to do the 4 quadrants, so the ones that run along the actual lines. So don't use your highlighter for this. I'm just going to show you. So here's the first one that we're talking about right here. This is where the angle starts, and if you don't go anywhere, then we call it a 0 degree angle. Does that make sense? Okay. So this one will be 0 degrees. And then we want the coordinates of this point right here. The coordinates of that point. The radius of the circle is always equal to 1. So the x value would be 1, and then the y value is 0. And we'll talk about which one of those is the sine and which one is the cosine in just a little bit, all right, once we start getting into the triangles. The next one would go up here, all right? And the angle is going to be from this yellow line. Everything's based off of this yellow line going up. And if you go up, what kind of angle did you make? 90. So this is your 90 degree angle. And then what's the coordinates of the point there? Its x coordinate is 0, because it doesn't go left or right at all from the origin. And then its y value is 1. Goes up 1. Radius is 1. All right, the next angle is going to be this side over here. Once again, it still starts at the yellow and comes all the way over. If you go all the way over, we're at 180. By the way, straight lines, right? They always make 180 degrees. And the coordinates at this point, your x value is going to be -1 because it is going backwards, right? In the x direction, that is the negatives. And then its y value is 0. And so what you'll notice is that you're going to have positive x's and negative x's depending on which quadrant you're looking at, okay? And last, well, not last but not least, but if you start here and you go all the way down to this guy, how far do we go? 270. You just keep adding 90, right? Add 90, add 90, and add 90. And its coordinate points are
0, -1.
0, -1. And then technically, you can go full circle. If you go the full circle, you end up back at the yellow line, right? But that is technically an angle. That is how many degrees?
360.
360. And once again, you'd be at 1, 0. Technically, you could go around more than once. You could go around once and then keep going, right? So if you went around to 360 and then you went up here, that would be 360 plus 90. So what, 450? 450 would be an angle measure. And so it is possible to go around the circle multiple times. And we're going to talk about that later. Okay, not today, like next week or, yeah, later next week. All right, so those are your 4 quadrants. Those are technically what we call quadrantal angles. You don't need to know that, okay? You just need to know what their values are. You okay so far?
Yep.
All right, any questions? Good? Okay. We're going to do the 45, 45, 90 triangle next, all right? So let's go back.
Okay.
And so if I have a triangle that looks like this, 45, and you have a 90, the other one's obviously 45. The hypotenuse is 1. Why are we saying the hypotenuse is 1? Because we're going to use this on the unit circle and the radius is 1, all right? So the hypotenuse will always be 1. So how do I figure out the other 2 sides? Because we're going to want those values to use in our unit circle.
You must divide that by the square root of 2.
Yeah, take your hypotenuse and divide by the square root of 2 because you times to get the hypotenuse. So divide to get the side. Now you can't leave it, right, as 1 over the square root of 2. You have to rationalize. So how does that rationalize?
When you multiply that square root of 1, even the square root of 2 over 2.
Right, square root of 2 over 2. So you times the top and the bottom by the square root of 2. In other words, the square root moves up, right, and then you get rid of the square root on the bottom. Good. All right, because it's a 45, 45, 90, if this is the square root of 2, what's this side?
The square root of 2.
The square root of 2. All right, we're going to put the 45, 45, 90 on our unit circle. So grab one of your highlighters. And remember, everything is based off of this yellow line, right?
Yeah.
So if this is 0, 45 doesn't go quite to 90, it goes halfway, right?
Right.
So halfway is the middle line.
So we highlight that?
So highlight that line, and then if you want, you can draw the rest of the triangle in there so you can see it. And so that angle right there is a 45-degree angle. From this positive x-axis up, that's 45. And we need the coordinate points of the point at the end of that hypotenuse right here. So the coordinates of this point right here. Well, its x-coordinate is this side, right? And its y-coordinate is this side. And we already just said on the last page, if this is 1, then this side is not the same as the 1. It's the square root of 2 over 2. And this side is the same, right? So that means the x value of that point is square root of 2 over 2. The y value is also square root of 2 over 2. And so if we say anything about a 45-degree angle and we ask you to find sine, cosine, tangent, secant, cosecant, cotangent, any of those, all of those values are based off of the square root of 2 over 2 and the square root of 2 over 2. And so we're going to find all 6 of those right now for the 45-degree angle. So we're going to jump down here and find them all for 45. All right, cosine of 45. Cosine is the adjacent, right, over hypotenuse. So this is our angle, 45. It really doesn't matter, right? But adjacent would be this side. So square root of 2 over 2 over 1, which is just square root of 2 over 2.
Yeah.
So the cosine of 45 is square root of 2 over 2. So at any point for the rest of this trimester, if I ask you what the cosine of 45 is, you're just going to say square root of 2 over 2. Don't have to show any other work. That's what it is. If we want the sine, that is the opposite over the hypotenuse. So square root of 2 over 2 over 1, which is, again, square root of 2 over 2. Before we continue on, let's talk about these 2 real fast, all right?
Okay.
All right. We'll wait for Alexis because this is going to be, it's kind of an important little piece here.
He wants something from me. I had to let him know I'm doing schoolwork.
Be like, hey, Miss Bird's talking.
Yeah.
Don't say that. They're going to be like, you're lame. No, don't say that. Okay, so cosine of 45, that came from the adjacent, right? And then the sine came from the opposite. The adjacent side, that's where we got the x value from, isn't it? And the opposite side, that's where we got the y value from. So on our circle, the x value comes from the adjacent side, which is the cosine. So on all of these coordinate points, the x coordinate is always the cosine of the angle, and the y coordinate is always the sine of the angle. So this is the really nice thing about the unit circle is the cosine and the sine are the two coordinate points that you have, the x and the y. And the x is always the cosine because it's always the adjacent side, and sine is always the opposite, so it's always the hypotenuse, the y side, or the opposite, the y side, right? Pretty cool, huh? All right, now all your other trig functions are based off of sine and cosine, even tangent, and we're going to talk about that tangent real fast. So tangent of 45, how do I find the tangent of that angle?
Tangent be opposite over adjacent.
Opposite over adjacent. Opposite, square root of 2 over 2, over square root of 2 over 2, which is equal to 1. Yeah, so the tangent is just equal to 1. And by the way, that was opposite, which is the y, which is the sine, right? Over adjacent, which was the x, which was the cosine. So tangent can always be thought of moving forward. Tangent is always sine over cosine. So if you know the two coordinate points, you can find cosine, you can find the sine, and you can find the tangent. And if you know those three, you can always find the other three, right? Because they're just reciprocals, yes? So knowing the coordinate points on the unit circle help you find all of these possible angles pretty quickly. Okay? All right. I always do that. So we are going to find the other three real fast for 45. So we have cosine, sine, tangent. So secant is what? The opposite of cosine, right? And so you're going to take the cosine and flip it around. So it's 2 over the square root of 2. And you can't leave it like that, right? So you have to rationalize. So that would make it 2 square root of 2. And then on the bottom it would be a 2. And then technically that does simplify, yes? To just the square root of 2. So if the cosine is square root of 2 over 2, the secant will always be square root of 2. What about the cosecant? Since cosine and sine are the same thing, secant and cosecant should also be the same. This is also going to be square root of 2. For the same reason, you would flip this one around, rationalize, and it would turn into square root of 2. All right, what about the cotangent? 1. Yeah, it's the reciprocal of 1, which is just 1. Absolutely. All right. We're not done with this 45-degree triangle, all right? So this is just the one in quadrant 1. There are actually 3 more 45-degree triangles in this circle. What was that? And they're all the middle ones for all 3 quadrants, yes. So let's do this one next. It'd be this guy, right? Coming up there. It drops down and makes your 90-degree angle. And this side, right here, the inside of that triangle is your 45. This side right here. Okay. So what is the angle measure of this line? Because the angle measure is not 45. The angle measure is based off of this one. So it's from here all the way up to that guy, and this side is 45. So what is it?
Well, it could be that way.
This side's 45 from the line here down to this axis, right? And we need this side.
Which are you?
We know this one's 45. We need this, and we know the whole thing technically, right?
Yeah, it'll be 180 minus 1/3.
180 minus 45. So 180 gets you to here. Go back 45 because it's a 45 triangle, and you'll get you to this angle measure. And 45 minus 80 is 135. 135. And so we need the xy coordinates of 135. Well, since it's a 45, 45, 90 triangle, the x and the y are still square root of 2 over 2, right? Because that's not changing. What's changing is now they're not both positive. Because we're going this way in the x direction, the x value is now negative. But since it's going up for y, the y value is still positive. So instead of both square root of 2 is over 2. They're both that, but the x is negative. So if I said, what's the cosine of 135 degrees, what would you say? Negative square root of 2 over 2, yes. If I said, what's the sine of 135 degrees? It'd be the positive, the y value, right? If I said, what's the tangent?
Tangent will be just the sine divided by cosine.
You would take these two and divide them, and when you divide them, you get a, not a 1, but negative 1, because one of them is now negative, right?
Yeah.
So you would divide them, you get negative 1. If I asked for the secant, right? That's the opposite of cosine. It would be the opposite of this, right? The reciprocal of this, because this is negative. Your secant is also negative, so it'd be negative square root of 2.
So
No, because it's in this quadrant. If you're talking about cosine, secant, which is the reciprocal, will also be negative. Yeah. And then if I were talking about cosecant, the one that goes with sine, it's going to be a positive square root of 2 because sine was positive. And then cotangent would still be negative 1. So this angle right here has the exact same values as this angle, only some of them are going to be negatives instead because of the negative for the cosine instead.
that's one thing though. If
What was
I'm doing that way, then that would be the biggest would be considered as negative 1. You want to say that way.
Yeah.
So that means possible you have a negative radius. I mean,
You can still think of your radius as positive 1, but just know because technically we're assigning it on a quadrant that you can denote positives and negatives accordingly. But if your radius is positive 1, because of the Pythagorean theorem, you know how it's always radius squared, whether it's positive 1 squared or negative 1 squared, it's still 1. Yeah. So really you should, instead of focusing so much on the radius being positive or negative, it's always the x's and y's that are positive, negative. Yeah. All right. Quadrant 3. 45 is the one right in the middle. Coming up, this one goes up to the x-axis and then would run back across there. Angle measure for this one. Remember, it starts at the 0 line and comes all the way over.
I mean,
225.
225, yeah. 180 plus 45 in this case. So it's 180 minus to get quadrant 2, 180 plus to get quadrant 3. And in this quadrant, there's still square root of 2 over 2's. That's not changing because it's still a 45-degree triangle, right? But in this quadrant, what do we do with the negatives? Say it again. They're both negatives, yes. Both negatives. So cosine, negative square root of 2 over 2. Sine, negative square root of 2 over 2. Tangent,
tangent would be 1.
positive 1. Yeah, positive 1. And then if you were to do like secant, right, that would be the square root of 2, but it's going to be negative because cosine was negative. Cosecant would be negative square root of 2 over 2. Cotangent is also a positive 1, yeah. So once you know one of them, you know all of them, except for some of them might have negatives in there.
Right.
All right, last 45. This guy right here. Angle measure. 270. This is 270. So you did 45 from there. You need to go 45 more. 315. You could also find this one by doing 360 minus 45. All right, and once again, the x and the y at the coordinate point are square root of 2 over 2, square root of 2 over 2. Which one's negative though?
Divide.
The y value is the negative 1 in this case, so that one's negative. And once again, I could say, hey, what's the cosine of 315? And cosine is the x-coordinate, so you give me the x-coordinate, right? I could ask for the tangent of 315, and tangent would be sine over cosine, so that'd be a negative 1, right? So we can ask for all of those values. So the nice thing is if you're working with either any of these four values, they're based off 45, 45, 90 triangles, and your answer will be one of these options. It's either square root of 2 over 2, 1, square root of 2, and it could be either positive or negative depending on where we're located at. What was that? Memorize the circle or memorize these? Hopefully we use them enough that you know them, but yes, you're going to need to know them.
Alright.
All right? Say it again. Yeah, the best thing to do is just make it over and over and over again. Just keep making it, all right? And the reason I didn't just give it to you and be like, here, memorize this, is because I want you to understand where it's coming from. Because if you know where it's coming from, it's going to be easier to memorize. So, all right, up next, we're going to go ahead and move on to this angle measure here, all right? And that's the 30 degrees. So we're going to talk about the 30-degree triangle and get all four of those on there. All right, so I have a 30-degree triangle over there. By the way, if it's 30, it's 30, 60, 90, right?
Yeah.
All right, and if the hypotenuse is 1, using our relationships, there's a couple things we should know.
One is that whether it's 1 for the hypotenuse, you can divide by 2 to get
The short side, right? So the relationship is whatever the shortest side is across from the 30, you times by 2 to get your hypotenuse. So divide by 2 to go back. So that side is 1/2. And then to get this side, you take this one and multiply by the, so 1/2 times the square root of 3 is the square root of 3 over 2. So when we put our 30-degree measure on there, our x value is going to be square root of 3 over 2, and our y value is going to be a 1/2, okay? All right, so switch highlighters. New color. All right, so here, that line right there makes the 30. And we said the x value is the square root of 3 over 2, and the y value is 1/2. 1/2. So the cosine of 30 is square root of 3 over 2. The sine of 30 is 1/2. The tangent of 30, you'd have to do 1/2 divided by the square root of 3 over 2, right? So we're going to do that. So let's go back, and we'll figure out all the possible values for these 30-degree triangles. So we said cosine, that was the square root of 3 over 2, right? The sine, that's the 1/2. So tangent is found by sine over cosine, or opposite over adjacent, right? So we're going to have to do a little bit of work here. I'm going to put it on the board over here so y'all can see. So it would be 1/2 divided by, come on, it's being stupid. There we go. Square root of 3 over 2, okay? And we're going to have to evaluate this. So how do you divide a fraction by another fraction? So you take the bottom one, flip it over, and multiply, times by the reciprocal. And when you go to multiply this, since there's a 2 in the numerator and a 2 in the denominator, those 2's are going to simplify, right? They're going to go away.
Yep.
So this would be 1 in the numerator, square root of 3 in the denominator, which can't stay. So it's square root of 3 over 3. So that makes the tangent of 30 the square root of 3 over 3. All right. Now I will tell you that this is one that you are not going to want to have to do every time. You're just going to know if it's 1/2 divided by square root of 3 over 2 that it is square root of 3 over 3. All right, so that would be one of those facts that I would say just get in your head. Just memorize it because it's going to save you a lot of time, all right? Tons of time. All right, so if I ask for the tangent of 30, this is technically what we would have to write out. But from now on, since you've seen it, you can just say tangent of 30 square root of 3 over 3. All right, secant of 30. Secant is the reciprocal of,
Secant is
3
R.
over 2, so it's 2 over 3.
yeah, so this is 2 over the square root of 3, right?
Yeah.
Which has to be rationalized. So 2 square root of 3 over 3. Once again, that's one that if you can just memorize it, you have it in your head, that's going to be easier for you to do. Cosecant of 30, that's the reciprocal of sine, which
2 over 1 is
2 over 1, which is just 2. So I wouldn't say memorize that because that's really easy.
Yeah.
And then the cotangent is the reverse of tangent, right?
That would be 3 over the square root of 3.
Yeah. So what's going to happen there, and I'm just going to show you, we'll write it out. This is actually square root of 3 over 2 divided by 1/2. It's the reverse of this, right? And so that would be square root of 3 over 2 times 2 over 1. And so what's going to happen is, once again, the 2's will simplify, and this is just square root of 3 over 1, which is just square root of 3. So this division is actually a little bit easier than that division. So the cotangent, square root of 3. Now on all the other 30-degree triangles that we're going to make, your answer would be matching this, except for it could also be a negative depending on which quadrant. All right. So let's go ahead and we will do those other 3. So we have this one here. It's going to be mirrored. That guy there. What is its angle measure?
120.
Close. Look at which one I made. I made this one, going back. So this angle is 30. To here, this side is 180.
60.
So it's 150, right? You told me this one up here.
Yeah.
Yes. It's 150. So it's 180 back. All right. The x's and the y's aren't going to change. So it's still square root of 3 over 2 and 1/2 in that order. But one of them is going to be negative because we're in a different quadrant.
It's negative square root of 3 over 2.
Yes.
Yeah.
And positive 1/2. Yes. So if I asked you for like the tangent of 150, it would be the same thing as the tangent of 30, but it's going to be a negative. If I asked you for the secant of 150, it's going to be the same thing as the secant of 30, but it'll be a negative. If I ask you for the sine of 150, it's the same thing as the sine of 30, and it literally is the same thing. It's not even a negative at that point. Yep. All right. Okay, next one. That is this one right here. Going down, flipped over. So angle measure there.
No. The change?
210. Yeah, 180 plus 30, right?
Mhm.
And then once again, it's square root of 3 over 2 and 1/2. And in this quadrant, they are
There you
both negatives.
They're all going to be both negative in that one.
Yeah, in that quadrant, they're all going to be negatives, right? In this quadrant up here, only the x's are negative. In this one down here, only the y's are negative. All right, so here's the last 30-degree triangle. It is right there. Its angle measure,
go. It's like 3, 0.
330.
Yes.
And then square root of 3 over 2 and 1/2. And in this quadrant, which one's negative?
The 1/2.
The 1/2. We got it. So if I said anything about the cosine of 210 or the secant of 330 or the tangent of 330 or the cotangent of 210, it's all based off of the 30-degree angle. We call the 30-degree angle the reference angle, and then you would just have to make the answer positive or negative. Okay? But for all 4 of those angles, you're using these values. For all 4. You just might have a positive or a negative. All right, ready for the last set?
Okay.
All right, that's the cosine of 60, or the 60-degree angle, right? The nice thing about the 60-degree angle is, guess what? It also comes from the 30, 60, 90 triangle, right? So in this case, if this is our situation, the 60-degree triangle looks like this. Still 1 for your hypotenuse, but what's happened is instead of this side being the 1/2, this side is the 1/2. And then instead of the x being the square root of 3 over 2, the y is now the square root of 3 over 2. They just flip.
So that just make it the design.
Yeah, so on your unit circle, here's your 60. And instead of the square root of 3 over 2 and 1/2 for the 30, they're just reversed. 1/2 goes first. That's the x, 1/2. And then your y, square root of 3 over 2. So the nice thing is if you know the 60, you pretty much already know the 30s, right? Or sorry, if you know the 30s, I said that backwards. If you know the 30s, you kind of already know the 60s. They're just the reverse of them. All right, you want to finish filling this in? So we have this angle here. What's going to be the angle measure for that guy there?
$120.
120, yeah, 120. You can either say, all right, 180, go back 60. Or technically from the 90, you go forward 30, right? And the x is 1/2, the y is square root of 3 over 2, except which one's negative? The 1/2. And then down here, quadrant 3, we have that triangle. Angle measure in quadrant 3, down here, 240. 180 plus 60, right? And then we have 1/2, square root of 3 over 2, and they are both negatives. All right, and last but not least, 4th quadrant, angle measure is 300. 1/2, square root of 3 over 2. Which one's negative? Square root of 3 over 2. So if I ask you for 60 or 120 or 140 or 300, they're all going to have the same values, and we'll put them on the other sheet in just the back sheet in 1 second. But the only difference between them is depending on what quadrant you might have positive or negative. All right, so let's finish. We'll fill out these 60 here, 60 degrees, and then you'll be good to go. All right, so cosine of 60. So if you need to go here, cosine, remember that's the adjacent, right? So that's the 1/2. And that makes the tangent, or the sine, square root of 3 over 2. All right, so for your tangent of 60, that's the sine over the cosine, right?
Sure.
So for tangent, I'm going to write over here, square root of 3 over 2 over 1/2. And we have already done this calculation. When we did it over here, what did we get? The square root of 3. So when you do it over there, it's also the square root of 3, yes. So if you memorize this one and it's reverse, it's going to make life a lot easier. All right? All right, secant of 60.
Secant will be just the object cosine to be 2.
2, reciprocal of 1/2. Cosecant of 60.
Will be, that will be 3 over 2 by the square root of 3 and
2 over the square root of 3, which does rationalize to 2 square root of 3 over 3.
Yeah.
By the way, we did that calculation here already, right?
Mm-hmm.
And then cotangent
Would be just the opposite of tangent, so.
is the opposite of tangent, or you can think about it as the 1/2 over the square root of 3 over 2, right?
Mm-hmm.
And we did that calculation up here, and we said that that one was
The square root of 3 over 3.
square root of 3 over 3.
So, that's a simple
Yes.
thing.
And then for each of those angles, the 120 or the 210, what's the last one? 330? Nope, 300? 300? For any of those angles that are part of the 60-degree set, it's one of these numbers, right? But you could also have a negative, depending on if the cosine or sine were negative. The nice thing is pretty much all the trig that I'm going to ask you for most of the rest of the trimester, the answer is here, and it's either plus or minus, depending on which quadrant. Does that make sense?
So I guess in the,
Yes.
so I guess in the most, with that case, you can see the plus and minus.
Plus or minus. Yeah,
The most original.
pretty much. Plus or minus. Plus or minus, plus or minus. All right, I'll be back. I'm going to talk to you more about some others. Miss Bird? What's up? Yeah. So, your assignment in your packet, here's what it looks like. It is a bunch of sines, cosines, tangents, cosecants, secants, cotangents, and I give you a specific angle. All right, a specific angle. So your job is to tell me what is the value at that point. So if it was cotangent of 240, use this, right? 240 is here. So it's based off of your 60-degree angle, and you need the cotangent. Cotangent is the opposite of tangent. Ooh, write this down. Can't believe I didn't write this down yet. Cotangent is cosine over sine. The reverse of tangent, right? So if I'm talking cotangent of this angle, it is sine over cosine. So it'll be a negative divided by negative, so it is positive. And it's 1/2 over the square root of 3 over 2. And we said 1/2 over the square root of 3 over 2 was square root of 3 over 3. So the answer to that first question is square root of 3 over 3. So you're almost following, it's kind of like, yeah, it's kind of like a maze. You're kind of working your way through. So for number 2, it says cotangent of 315. So 315 is here. It's based off the 45, 45, 90 triangle. But cotangent is, once again, cosine, so the x over the y. Since they're the same, when you divide them, you'll get 1. But one of them is negative, so your answer is -1. So number 2, the answer is -1. All right, let's talk about the next one. Secant of 270. 270 is this guy. He's kind of unique, isn't he?
Yep.
Yeah, and so secant is 1 over the cosine, and cosine is 0. So the secant is 1 over 0. What's 1 over 0?
1. Wait, 1 over 0.
1 over 0.
Error.
That's an error, right? That's undefined. So the answer for number 3 is undefined. So the secant of 270 doesn't exist. By the way, there's only a couple that don't exist, and that happens at these numbers when you try to divide by 0.
You said number 4?
That was number 3. Secant of 270 was undefined.
Okay.
Does that kind of make a little bit of sense what you're doing on this?
I think so.
Yes.
It
Okay.
should be okay.
Yeah.
Probably.
All right. After when y'all come in on